Okay, today you're going to be looking at the unit rate as the scale factor. Your objective today, I will demonstrate my mathematical ability to use a scale factor to determine the proportionality of an original drawing and an enlargement or reduction through class discussion. Okay, a couple things to remember. Our constant of proportionality, or our K, remember K equals Y over X, or my dependent over my independent variables. Okay, and this, if something's proportional, this is always going to be in common. Now also remember that my constant proportionality is also the same as my unit rate, and that is a rate of change. It's how something is changing. We're going to look at that when we're looking at scale factors today. And then another thing to remember is our independent and dependent variables. Remember, independent can stand by itself. Okay, I don't have to depend on anything, whereas my dependent is going to depend. So this is going to be, the independent is going to be my original drawing, and then this is, the dependent is going to be my scale. Okay, if that helps a little bit. And then we really haven't talked about this a whole lot, but there's two different types of scale drawings. The first type is called an enlargement. And this is what happens. Say you take a picture on your phones, okay, and you really like that picture, and you want it, but you want a bigger picture of it. So I'm actually going to enlarge the picture to make it bigger. Okay, but say I have this really big thing. For example, our new buildings, the new middle school for where Wes is going to be at. Okay, I want to actually see what that's going to look like. Well, I can't have a picture of the actual building with the actual dimensions because it's going to be too large. I don't have enough paper or enough room to even show that. So I have to reduce it or make a reduction drawing of it where I can reduce it down to a size where we can see I can reduce that down to a piece of paper, and we can look at that piece of paper and everything is proportional to it. Okay, it's important to remember that with scale drawings we're looking at proportionality. If they're not proportional, it's not going to look right. It's not going to look professional. It's going to look sloppy. Alright? Let's look at the first problem and kind of see how, well, before the first problem, I'm going to show you some other things to look at. When we're using scale drawings, some steps that you need to make sure you know to check for proportionality. The first thing is I want to measure the lengths of the scale drawing, and I'm going to record those onto a table. That's that XY table. Okay? Remember, Y is my scale drawing, and then, so this would be my Y, this would be my X. Measure the corresponding lengths on the actual drawing and record that on a table. Then I'm going to check for proportionality, which Y, or K equals Y divided by X. None of this has changed since we started. Okay? Now, I've talked about the scale factor. The scale factor, which is what we're going to use throughout this lesson today, can be calculated from the ratio. Remember, a ratio is like A over B. It's a fraction of any length in the drawing to, this is important, right? That's the 2, the length of the scale drawing to its corresponding length in the actual drawing. Okay? So scale over original. We can see that in a number of ways because the scale is listed first, and then 2, its actual length is listed second, top, bottom. Also, Y over X. Okay? The scale factor corresponds to the unit rate and the constant proportionality. This is really important to know when we're looking at scale factors. Okay, if I am scaling by factors greater than 1, so like 3, 5, greater than 1, I'm actually going to enlarge the segment. However, on the opposite, if I am going to scale by factors less than 1, like 1/2, 1/4, 3/8, that's going to reduce the segment. So if I want an enlargement, it has to be greater than 1. Like 1 1/2 would enlarge it. But if I have a factor less than 1, like 5/16, I'm going to reduce my actual drawing. Okay? Let's kind of look at how this plays out. Ruben has created a simple game on his computer and shared it with his friends to play. They were instantly hooked, and the popularity of this game spread so quickly that Ruben wanted to create a distinctive icon. so the players could easily identify his game. He drew a simple sketch, and then from that sketch he created stickers to help promote his game. But Rubin wasn't sure if the stickers were proportional to his original sketch or not. Okay? Now, what I did is I did the first two steps already for you. Okay? Let's see if I can move this down a little bit. Okay. So, this is my original, this is Rubin's original picture. It's a Rubik's Cube. Okay? And then this is the sticker he made. And I want to know, is this proportional to this? Okay? Now remember, now that I have my table, that my original is my X, my sticker is my Y. Like I've said before, I like to label things because labeling helps me. Now to find my K equals Y over X, right? Okay? So then I just simply would go through and check for proportionality. So 2 divided by 1 is 2. So the K here is 2, and I would go right down the middle. Now I go 1 1/2 divided by 3/4. Okay. Remember when I divide, I have the multiply here. 2 times 1 is 2 plus 1 is 3. So I have 3 over 2. Now I'm going to go ahead and flip the second one by 4 over 2, or 4 over 3 rather. Okay, I can cross reduce here, so I can get rid of my 3's because those become 1. Cross reduce here, that becomes a 2, and that equals a 2. Okay, so there's a 2 there, there's a 2 there, because that's the same as the first one. I have 1 3/4 divided by 7/8. Okay, 4 times 1 is 4 plus 3 is 7. 7 over 4 times 8 over 7. I went ahead and flipped the second fraction. Cross reduce here. That's 1. I cross reduce here and here. That's 2. And I multiply across, I'm left with 2. So my question here then is this proportional? Well, we can look based on all the measurements that we found and find the K that is proportional. Okay? Now, so the corresponding lengths are proportional. Now, how do we know that? Well, I know that because my K is 2, which means that my original, that my sticker is twice the size as my original drawing. And we can kind of look, if we look at that, look at our original drawing here, we can see that it is about twice, that the sticker is about twice the size of that. And we have proven that mathematically by finding the scale factor. Okay? Remember, this is called the constant of proportionality. Now, when we're talking about the scale factor, is a new drawing or sticker larger or smaller? Well, it's larger, so this would be an enlargement. Okay. Now, and then the scale factor. Okay, if I want to know what the scale factor of this drawing is, okay, remember our ratio is 2 over 1. I can write that as 2 to 1, correct? So for every 2 inches on the drawing, I'm going to have 1 inch on the actual deal. So my scale factor here is a 2 to 1 scale factor, which means the lengths are 2 times larger. Now, if I do, say I have a scale factor of 3, how is that going to change? Well, it's going to be 3 times larger. So instead of having 1 to 2, I'll have 1 to 3. Okay? Now let's look at another problem. So I have a special effects engineer from a movie production company who is building a 1/5 scale model of the airplane shown below. If the height of the actual plane is 2.8 meters, what will the height of the model be? I want you to express your answer in centimeters and round to the nearest tenth if necessary. Well, I'm going to first find out how many meters it is. So my scale is 1/5. Okay? And then my height is, or my actual drawing is 2.8. So all I'm going to do is multiply 1/5 times 2.8. Okay? Well, you could do it one of two ways. I could take this to a decimal or take this to a fraction. Since we've been working in fraction, I'm going to take this to a fraction. I know that 0.8 is 4/5. So I'm going to have 1/5 times 2 4/5. Okay? Now I go improper. So 2 times 5 is 10, plus 4 is 14. So I have 1 over 5 times 14 over 5. Okay? Now I'm going to multiply across. I'm going to have 14 over 25. Okay? Now, this is so 14.5 meters is what I'm going to be dealing with. But I need this in centimeters. So I need to multiply, well, so I could leave it like this, and this would be an acceptable answer because this is my fraction. Okay, however, I need to know centimeters, so I'm going to actually have to divide a little bit. So I have 14 divided by 25. Okay, 25 doesn't go into 100 or into 14, so I got to add a decimal and a 0. 25 goes into 145 times, because that's 125. Okay, I'm going to subtract. I got to borrow. 10 minus 5 is 5. 3 minus 2 is 1. Bring down another 0. 25 goes in 156 times. That's 150. I'm up to 0. So 14 25ths is 56 hundredths. Okay, remember from 6th grade that if I go meters to centimeters, I have to multiply by 100. So I take 0.56 and I multiply it by 100. I'm going to get 56. So my answer is 56 centimeters. Okay, and all I did is I took my scale factor and I multiplied it by my original length. Okay, and that's how I found that. So I can just multiply if I have the scale factor to find out what my scale factor or what my scale length is going to be. All right, let's see what I have next planned for you. Okay, I want you to make sure that somewhere in your notes you have the answers to these 3 questions. Okay, I'm actually giving you the questions that I want to have in your notes today. So the first question: what is the constant proportionality, and how does it represent the scale drawings? Okay, and we've talked about that. So if you don't know it, you go back and rewatch the video until you find it. The other one: what steps are used to calculate scale factors? There are 3 of them you need to have written down. And then what operation or operations is used when we create scale drawings, and how is it used? Not only what is it, but how is it used? Give me an example. All right? Now make sure you fill out your WSQ and bring everything to class. I'll see you in class.